All right, folks, the next of these coordinate geometry things. Earlier we talked about special right triangles. I showed you how trig could be used. I am a trig guy. That is what I do. I hate special right triangles. And you are going to notice I'm going to show you some trig to help you come up with some other things in coordinate geometry later on. Before we do that, we should go through some very basics. If you understand these three topics, you may want to flip through this particular note and see at the end. I'll see if I can repost the questions in the last couple minutes that we asked. There are some interesting things they could ask you, but what we are going to do is we are going to look at three super simple concepts in coordinate geometry, the concept of midpoint, slope, and distance. Let's begin with midpoint. What is a midpoint? You ready for this? It's the point in the middle of a line segment. It is the location of the point in the middle of a line segment. And we're going to use the concept of we're using a line segment specifically because it will stay on the line. We're also using a line segment because, well, if this is a ray, then the midpoint will be somewhere around infinity. And if this is a line, the midpoint will be somewhere around 0. It'll either be somewhere around 0 or somewhere at infinity, guaranteed. It's weird stuff, this midpoint stuff, when we start dealing with lines and such. But we don't have to worry about that. We're going to deal with the line segments. So we're going to start off really simple. Let's say I'm on a number line. Boop, boop. And I have 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. I have a number that exists at the 1. I have a number that exists on the 5. I would like to know where the middle is. I will give you 3 seconds. All right, your 3 seconds is up. If you said the number was 3, you win. Yay, you're so smart. The question is how do we get that? And what most of you probably did is said, well, 3 is 2 steps from the 1, and 3 is 2 steps from the 5. Maybe some of you actually came up with some sort of snazzy way to do it. We'll talk about the snazzy way to do it in just a minute. But now let's pretend that the question maybe was a little bit harder. Maybe I didn't make this 1, 2, 3, 4, and 5. In fact, I'm going to get rid of some of these things. In fact, I'm just going to get rid of the whole picture. But rather, let's pretend I'm still on a number line. I want to make sure that this is good and understandable. And I'm going to put this number as negative 372, and this number is 2,756.3794. And I want to know, what is the number that exists right here, where the distance from the left endpoint to here, let's call it a distance x, is the exact same distance from the right endpoint to that center value. Now we've got ourselves a situation if you don't know how to find the midpoint. So how do we do that? Fairly simple concept. Would we go through there? Essentially what it comes down to is finding an average location. Lines are interesting in that we like to use average a lot in them. And if we wanted to find the average location, what we would do is we would add up all the pieces and divide by the number of pieces that we had. In this case, we had 2 pieces. We had 2,756.3794 plus negative 372, and we would divide that by 2. And if we did that with our calculator, because I don't really want to do it with my head because it's late, kind of, and 3794 minus 372 divided by 2, we find out that the point is going to be 1,192.1897. 1192.1897. That's this spot right here. Now, just to prove that that's the case, if you do 1192.1897 and subtract the negative 372 from that, you get a distance of minus negative 372, and you find the distance there. This is a grand total distance of 1564.1897. And if you do the same thing here and you do 2756.3794 minus 1,192.187, you get a distance of 1,564.1897. Oh, look! Ah, 2,756.3794 minus that, and you get this distance. That is the concept of the midpoint formula. We're trying to figure out the average distance from the one endpoint to the other. Since we're trying to find a spot where the distance will be the same, we find the average location, and we do that. But Mr. Ackerman, you know that they're going to make these questions harder than that. Clearly, they're going to ask me to do some other weird stuff. Sure they are. For instance, one of the weird things that they can do to you is they can turn this not into a one-dimensional problem, but into a two-dimensional problem. What, you say? How do I do this problem in 2 dimensions? Well, let me show you, young grasshopper. Let's assume that this is the point negative 3, 6. Negative 3, negative 6. And let's make this the point 7, 2. And I want to know right here, when does this midpoint occur? Now, an interesting thing about this is that there's 2 different things that we can look at. We can look at the midpoint in terms of the... Oops, I didn't want that. Let's do it in red. I want a color. I can look at this in terms of the distance between the x-axes, like so, and figure out when the distance between negative 3 and 7 is. And I can also do the same thing if, oh, that's way too similar. I look at the distance between the y's here, and I find out the distance between negative 6 and 2. And so what I could do is I could deal with the x's and the y's as independent things. I can deal with the x's by saying, well, for the x's, this would be negative 3 plus 7 divided by 2, which would give us 4 over 2, an answer of 2. And for the y coordinates, I could use the negative 6 plus 2 over 2, which is negative 4 over 2, which is negative 2, which would be this point right there. Now, an interesting thing. So I did the x and the y as separate pieces. And what you have is you have an ordered pair 2, negative 2, which happens to be the answer. You see, the midpoint formula, now that you've seen all of this, really is just an ordered pair finder where I say take the 2 endpoints and find their average values. And if you do that, that should be a y. You have yourself a location. Now, at the end of the video, what I'm going to do is I'm going to talk about specific questions that you might be interested in with the midpoint formula. They won't always ask you something as straightforward as here's a point, find the midpoint. Other things that they might do is they might give you, one of the ones that I'm expecting them to do is they give you this, the midpoint and another value, and they want you to find the opposite end. So be aware of that. We're going to take a look at that momentarily. Next, after the midpoint, I want to talk about our favorite thing, slope. All right, seriously, I don't know what type of things you jokers need for slope. What is a slope? It tells you how fast a line is either increasing or decreasing. An increasing line will have a positive slope. A decreasing line will have a negative slope. Slope can be written many different ways. We can call it rise over run. We can call it what you probably need to know for this class, y2 minus y1 over x2 minus x1. And of course, my personal favorite, no, it's not m. I like to call it delta y over delta x. Hopefully at some point in time, my calculus students here are sitting there going, but Mr. Ackerman, what about dy dx? That's the last section. Just chill. Questions about the slope formula? I'm not going to do a slope formula introduction, folks. There's the equation. You know how to do it. I might throw an example problem towards the end, again looking at specifically what type of weird things they could ask you. Last, but certainly not least, we have the distance formula. So what is the distance formula? Well, the distance formula is kind of an interesting little monster. Let's say that I have 2 points. Those points are 3, 5, because I don't want to deal with negatives right now. And, oh, I will. Negative 3, 5, and 10, 9. And I wanted to know precisely how long this stretch, I shouldn't do that in black, I should do that in red. Precisely how long this stretch is. Now, to most students, they go, well, that's not too bad. Let's just add how far this is. This is 13 plus 4. That distance is 17, right? And the answer is going to be no. That's a terrible idea. Don't do that. Don't have terrible ideas. What we need to realize is that this particular shape can actually be can turn into a triangle. You were actually coming up pretty close with that other idea. But what we need to realize is this shape is really a triangle, where this piece right here is equal to the furthest point minus the negative 3, just 13. And up here, this would be 9 minus the lowest point, 5. This has a distance of 4. So this has a distance of 13. This has a distance of 4. And if this is a right triangle with the legs 13 and 4, what we find out is, well, if this is a triangle, our homeboy Pythagoras says all we have to do is take 13 squared plus 4 squared, and that's going to be our hypotenuse squared, or the square root of 169 plus 16 is h squared, which is clearly the square root of 185, or sorry, not h squared, that's just h now. And that answer is going to be terrible and horrible, and if you can't simplify a radical, then what the heck are you doing taking upper level math? Hopefully you can do that. Otherwise, just type it into your calculator, because I don't have time to go through and figure that out for you. If you want to figure it out, come ask me outside of class. What we get in the distance formula then is a really easy formula to understand. What it says is that the distance is equal to the square root of the distance between the x values squared plus the distance between the y values squared. And if we just plug in the numbers, we can get the final distance. Now, one of the things that they're really interested in doing is evaluating the distance from a, oh, I would really want to be able to put a coordinate grid up, but I really don't want to draw one. But they'll give us a line. Oh, that bothers me. I want an actual line. They'll give us some line that exists, and then they'll give us some point that exists. And they'll ask us, what is the, I'll call that AB, this is going to call it line L, and the question will be something along the lines of, get it, line, no, along the lines of, what is the distance from, I'm going to call this point P, from L to P. And, you know, what winds up becoming interesting is, well, it depends on which distance we're talking about. Are we talking about this distance, or this distance, or this distance, this distance, or this distance? There's an infinite number of distances you could ask me to find, Mr. Ackerman. And so please understand, in a question like this, it's the shortest distance, and we don't quite have the method of doing that yet. It's a little more difficult to deal with than one might imagine. Requires us finding where the heck this other point is. Actually, I believe it's this point, where we're perpendicular to the curve, or to the line itself, and then we can come up with an answer. So it's an interesting question. It's not a hard question. So what type of questions could we ask? Standard midpoint question might be this. If the midpoint is 3, 6, and and endpoint is 7, 5. What is the other endpoint's location? A little bit different. So what we have to do, and this is actually a very easy question to figure out. So what do I know? I know my midpoint is 3, 6. I know my endpoint, 1, is 7, 5. So how far away is the distance? Endpoint, I'll call it endpoint 2. Call this endpoint 1. So if this is 4 away from here, then this has to be a distance. Since this distance right here is 4, and the distance between these two values has to also be 4. So what's 4 backwards of 3? Since we went forward to get 3 up to 7, we have to go 4 back from 3 and get -1. Boom, you're done. To go from 6 to 5, we had to go -1, so we probably need to increase by 1 here. So this is plus 4 minus 4. This is -1. This is going to be distance of +1. So what's that? 7. There you go. -1, 7. Easy question, easy peasy, you've got it. Slope problem that they might ask. They might ask if slope is 3 and 1 point is 2, 9. What is the x value of the other point if the y value is 11? So what do? Well, I know that my slope 3 is equal to what do I have? I have 2, 9 as my x1, y1. So for my x2, y2, I've got x and I've got 11. So this is x2, y2. And I simply substitute that into my formula. 11 minus 9 over x minus 2. Oh, I don't want to put an equal sign there. Multiply the x plus 2, x minus 2 over here. I'm going to divide that 3 out. This becomes x minus 2 equals 2/3. Add the 2. X is 2 and 2/3. 2.6 repeating. 8/3. Take your pick. Probably 8/3. That's what they'll want. And so those are just a couple of examples of simple things that they're going to do. Your biggest thing is going to be able to look at a problem and be able to come up with a method of attacking it. If you haven't been practicing problems from the workbook, I highly suggest you do that. Similar things for distance. I'm going to show you some more interesting distance questions that they're going to ask you later on. I hope this crash course on distance, midpoint, and slope was at least moderately useful. Remember, the biggest thing you're going to have to decide is which one do I use when. Midpoint is a location. Distance is going to be when they're measuring how far something is, or it's going to be when I'm talking about how far apart two things are. They'll mention the word distance. Slope is a measure of a rate of change. So if you can remember those three things and what they are and how to find them, you will probably be very successful on this upcoming AP test. Or not AP test, but on this AcDec test. That is the basics to this lovely, lovely thing known as coordinate geometry. It's an introduction at this point in time, so realize that. Next up, I've got perpendicular lines and properties of quadrilaterals. So I'm going to get through those, and I'll have those posted hopefully by tomorrow. And then we'll get into area and area of polygons, followed by surface area and volumes of three-dimensional figures, which I will not spend a huge amount of time on, properties of similar figures, and then finally end it with the terrible, 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 terrible thing that is circles. And we will be through all of section 2. All right. Good luck. Break a leg. Look forward to doing some more math with you.